All right, welcome class to 1.1D lesson. Today we'll be working on linear equations and real world contexts. So in the first few questions, we'll be given a list of expressions. And in this first problem, you'll see that their context is partially given. And our job is to look at the expressions and create a context. Okay, so let's begin. Theo is training for a triathlon. He runs twice as long as he swims. So twice as long as he swims, right? So we've done this, some of these problems in the past where you compare two things, uh, something as much as something else. He bikes and it's not given. And then it says he swims 3 times a week, runs 4 times a week, and bikes a certain amount of times per week. If he spends a total of 510 minutes per week training, how many minutes does he spend on each exercise? So I think it's important that we first understand that swimming is going to be our variable for x. Uh, and then every other form of exercise in this triathlon is part or compared to swimming. So if you look at running, you could see that running is twice as long as the swimming, 2x, right? And that's discussed in the first sentence. Minutes spent biking is similar to running, except it's 30 more minutes, right? So you could say he bikes 30 more minutes than THAN he runs. All right, very, very simple. He runs twice as long as he swims, and he bikes 30 more minutes. 30. Well, actually, I should have said 30 minutes more. Sorry, I apologize. 30 minutes more than he swims. Right. He swims 3 times a week, runs 4 times a week, and bikes. So this is kind of like the number in front of the group. It seems like he bikes twice a week. Okay. And then every context, a well-written word problem will always give you an ending question because it obviously wants the audience, which is you. It wants you to solve for not only the variable x, but also solve for all of the time spent on each event, right? How many minutes does he spend on each exercise? Well, obviously, if we're given the equation, I think you can solve the equation pretty easily. Remember that this training, what we're doing now, class, is basically we're giving you the expressions and we're seeing how the expressions relate to the context. Eventually, I can give you the context and you can create all of these expressions. Just like if we could teach you one way, right? Math is very, very cyclical. Like if you can go one way with math, you should be able to go the opposite way and go backwards. So we're so used to doing word problems with a paragraph of sentences, but this lesson is now showing us that if we were given expressions, we can also convert them to contexts or paragraphs or sentences that describe all of these expressions. Okay, let's go ahead and solve. So I'm just going to take this information here and I'm going to simplify it a little bit. We get 3x plus 8x plus 4x plus 60 is going to equal 510. And you should, let's also, add a little bit more description here, right? The 3x is because he swims 3 times a week. So this is the swimming per week. 4 times of running. So he goes running 4 times. And this is going to be running. And then the biking, which is 2x plus 30 every session. Theo went biking twice a week. So this entire thing is describing the biking. Okay. All right, so I'm going to go ahead and continue to add the like terms, and I get pretty much 15x plus 60 is going to equal 510. Now, I hope at this stage you've been practicing solving equations for a while, and when you reach this point, this is a 2-step equation. This should be pretty easy for you, and you'll see that the numbers actually work very, very well. This ends up being x equals 30. So each session of swimming is 30 minutes. And time spent swimming on each session is 30 minutes, right? And then that means the minutes spent running is going to be double that, which is 60. And then the minutes spent biking is going to be 90. And these are all in minutes. So let's go ahead and write that. Okay. So this is an easy equation to solve for, but I think hopefully we got some practice with how to convert these expressions into sentences. Okay. Let's go ahead and skip to number 3. So again, you can see how we're going in reverse. We're given the expressions. We're dealing with ages, and it says Talon's age now is T, and Peter's age now is 8T plus 3. Obviously, Peter's older. And for some reason, you can see in this equation, there's like a 4 added to each of their current ages. So a 4 added to their current age potentially is like saying something in the future, right? So where do we begin? Well, I think the first thing we want to do is we want to compare Peter to Talon. So how would you compare Peter to Talon? Would you say Peter is currently 3 years older than 8 times Talon's age? Yeah, let's write that. Let's say currently Peter is 3 more. Notice how we talked about the constant first in our context. Peter is 3 more than, I'm going to underline the word than, 8 times the age Talon is now. Okay, so that actually, in one sentence, I was able to get 2 kind of both expressions accounted for. So now this last part is the tricky part, right? We're adding a 4 to both their ages. So it's kind of like we're going in the future. And then we have this sum that's going to be 56. So think about how you would write that as a context. Maybe something like this. In 4 years, the sum of both their ages is 56, right? And then every context needs to have a kind of exiting question. If you don't add anything else to your context, then your audience will read your context and say, okay, what do you want me to do? Do you want me to solve for their age in 4 years, or do you want me to solve for their age now? So I'm going to write how old is each person now? Basically their current age. Again, class, the whole point of this activity is for you to be more and more aware of how word problems are written and how they basically, where each section of the word problem, each sentence translates to an equation or translates to an expression, right? Let's repeat. We just wrote one sentence. Currently, Peter is 3 more than 8 times the age Talon is. Notice how Talon is the noun after the comparison. So that kind of is a giveaway to tell us that that's going to be our variable. Peter, therefore, is compared to Talon. In 4 years, the sum of both their ages. So this is where you have to be a little bit creative and understand that we're adding 4 to both of them. And in 4 years, the sum of both their ages is 56, right? How old is each person now? Also, the solving portion of this equation should be the easiest part. So t plus 8t, the like terms are 9t. 4, 3, and 4 is going to give me 11, and that's going to be 56. Now, ideally, these numbers are whole numbers because when we're dealing with age, yeah, obviously some people will not be an entire full year, but this is a word problem for 8th grade math, so we don't want to make it too complicated, and this is going to be 45. So if you divide by 9, you get t is equal to 5. And once you know that t is equal to 5, you know that the answer, which we always have to write in a complete sentence, right? This is going to be, wow, Peter's 43. Is Peter his dad? Maybe. Who knows? But you would say Talon is 5 years old. And Peter is 43. Ta-da! All right. Hopefully these 2 examples went by pretty quickly for you and you understand them. You could continue working, maybe try number 4. Try number 4 on your own. And we can talk about this in class. Thanks for watching.